Hello and welcome back again to the course Comprehensive Slope Stability Analysis using PLAXIS 2D. This is tutorial number 31, Stability Analysis of a Reservoir Dam under Rapid Drawdown Condition using PLAXIS 2D. So we will focus on a stability of a dam when or under effect of a rapid drawdown condition. For example, as you can see, this example, we will simulate this soil stratigraphy and the geometry for this dam. As you can see, we have 30-meter one layer of subsoil, and also we have a core at the middle of the dam, and also from left and right we have a field for construction of the dam. So the geometry will be like this one. As you can see, the height of the dam is 30 meter, and we will consider this is a reservoir and it is almost full of the water. So we assume the first water level is 25 meter, and maybe due to some specific reason this water level suddenly drops to, for example, 5 meter. So we will simulate this situation in PLAXIS 2D, and we will see how this rapid drawdown of the water in the reservoir affected the stability of the dam. So as you can see in here, we have the water table in here, then suddenly the water table drops to something like this one. So what is rapid drawdown? It's an important situation or condition in a reservoir engineering that directly affect the stability of the dam. This condition occurs when the water level in a reservoir is lowered quickly, and maybe this is due to specific conditions such as during emergency releases or sudden operational demand or flood control, etc. So in this situation, the water pressure inside this dam and subsoil remains high, while the supporting water pressure on the upstream at this site, on the upstream of the dam face, drops suddenly, and this causes an imbalance in the stability of the dam. Also, we will consider the slow drawdown. For example, if this water level drops down in a short time, for example in 1 day, 2 day, up to, for example, 5 day, this is considered a rapid drawdown. But for example, if this dam this water level drops to, for example, like this one, in long duration, for example 2 months, this is called a slow drawdown. This situation occurs when the water level decreases gradually, not suddenly like the rapid drawdown. So in this condition, it gives pore water pressure enough time to dissipate. So this reduces the risk of slope failure. This subsoil using a borehole, and we assume the middle of the core is located at original coordinate 0, 0. So that's why I will start by creating one borehole, and click on here 0, 0, and I will add one soil layer in here, and so as you can see, the depth of the subsoil layer is 30, so it is from 0 to minus 30. So we set 0 to minus 30, And also we assume the water table is located 10 meters below the natural groundwater, below the natural ground level, and we click OK. I forget to explain the boundary contours for the geometry. So we click on File, we have Project Properties, and in the model, as you can see, we use a plane strain. So because we assume this is the original point, as you can see in here, and the total length in x direction is 260. So in here we set minus 130 from x minimum, and positive 130 at x maximum. Also for y minimum, so as you can see, because we assume from here, which is equal minus 30, so we set minus 30 at y minimum, and the maximum y coordinate, this one is equal 30. So we set this one to positive 30 meters. So we click OK. So we save the project again, and it's ready for calculation, and we can, for example, select a point for the curve. We can click on here. For example, I will select one point at here, and also one point at toe of the slope. So we click on update, save again, and we click on calculate. So we can see the calculation is started. Maybe it takes some time. That's why I will pause a video and come back when it is finished. So as we can see, the calculations are finished, and we don't have any error or warning. So first of all, we want to check the safety factor at each of these phases in case of full reservoir, rapid drawdown, after the rapid drawdown, and after slow drawdown, and also in case when there is only 5 meters at a reservoir. So first of all, we will check the factor of safety in case when the reservoir is full, 25 meters. So we click on here, safety factor in full reservoir, and edit a phase. And we can see the safety factor is 1.693. So the safety factor is 1.693 when the reservoir is full. Also, after the rapid drawdown, so in here we have the safety factor. If it's rapid drawdown, it means the safety factor after the rapid drawdown, we can see it is 0.9929. So it is less than 1, 0.9929 is almost 3. And also the safety factor after the slow drawdown, we can see it's increased. It's 1.219, and also in case of low level reservoir, we can see the safety factor is 1.788. So as you can see, we get the highest safety factor in case when there is a low water level at a reservoir. The safety factor is 1.788, and in case of a full reservoir, the safety factor is still high. It is 1.693. And the lowest safety factor is in case of a rapid drawdown, which is almost equal 1. And in case of slow drawdown, the safety factor is 1.219. Also, we can check the pore water pressure at each of these phases. For example, I click on a full reservoir and click on view calculation results. and you can see this is a deformed shape, and we click on stresses, and in here we have a pore pressure, active pore pressure. We can see this is the maximum and minimum pore water pressure, and if I click on contour line, we can see this is the highest water level in a fall reservoir. And after that we have a rapid drawdown. If I select this one, we can see this is maximum and minimum active pore water pressure, and in case of the contour lines, we can see also this one is the highest water phreatic level after the rapid drawdown. And this one for slow drawdown, as you can see, we have the water level a little bit more lower than the previous. And also in case of low level reservoir, we can see this is highest water level. Also we can see the safety factor versus deformation at this point which we selected before. For example, I click on curve manager and click on new. We will select this point, and in X direction I will select the deformation, and in Y direction I will select the safety factor. And as you can see, this is deformation and safety factor. I will only select the safety factor analysis. So for example, a safety factor for fall reservoir, for low reservoir, we don't need this one, and this one, and this one. So we click OK, and after that we can scale this one, for example, to maybe 50, apply, or maybe less, maybe 5. So as you can see, this one, the highest safety factor is in case of a low level reservoir, and this one for a high or fall reservoir. And the lowest one is the safety factor for in case of a rapid drawdown, and also this one for in case when we have a slow drawdown. So as you can see, it's like this one. So this was for this example. I hope it was clear and useful. Thank you for watching. See you in the next tutorial.